Today we will discuss the Thyristor turn-on methods. The various methods are forward voltage, triggering, gate, dV by dt, temperature and light triggering. In the forward voltage triggering, what we have, as you can see in the diagram here, the A is the anode and K is the cathode, where G is the gate. The junction J1 and J3 are already forward biased. Junction J2 is reverse biased. So problem is of junction J2. When we increase the voltage anode to cathode voltage, the width of depletion layer decreases of junction J2. This decrease would lead to an avalanche breakdown and the SCR starts conducting. The voltage at which this occurs is known as voltage forward breakover voltage. As we also have discussed the IV characteristics in which the graph shifts from M to N suddenly because due to this avalanche breakdown. Thyristor changes from off state to on state. Meaning of off state is high voltage and low leakage current, and on state means low voltage across a thyristor with large forward current. We know J1 and J3 are already forward biased, so junction J2 also gets forward biased by this avalanche breakdown. Next, we will discuss the gate triggering. In the gate triggering, we have we can give a pulse of higher amplitude to gate. What will happen with that? For example, if our forward breakover voltage is 800 volts, we can trigger the SCR at a very low voltage. As you can see in the diagram, as soon as the voltage increases, as soon as the gate current increases, Ig1 to Ig2 to Ig3, the voltage also reduces. That means what we conclude that by giving the higher gate pulse, we can reduce the forward breakover voltage and we can easily turn on the SCR at a very low voltage. If the gate current Ig is equal to 0 before rising of the anode current, there attains a value. For example, latching and the holding current. What is a latching current? Latching current is defined as the minimum value of anode current it must attain during turn-on process to maintain conduction when gate signal is removed. First of all, Ia is the anode current and it is associated with turn-on process. Turn-on process. And condition is also that when the gate signal is removed. That means, for example, the anode current is 100 milliampere. That means that to conduct the SCR, we should maintain the 100 milliampere value. If it is 99 milliampere and the gate signal is removed, the SCR will not conduct. Same like holding current. It is a minimum value of anode current below which it must fall for the turning off of the thyristor. That means it is associated with the turning off of thyristor, in which anode current must fall a particular value. For example, it has 100 milliampere, it must fall below this. For example, 99 milliampere or 98 milliampere. If it is 101 milliampere and the gate signal is removed, the thyristor will not turn off. It will only turn off when it goes to the value below 100 milliampere. It is just for an example. Also, there is confusion among the students of latching and holding current. You know that latching current is an turn on process and holding current is associated with turn off process. The value of holding current is basically 10 milliampere as written in the books. Also, we have dV by dt triggering. In this, already we have discussed in the diagram the junction J3 and J1 are forward biased and junction J2 is reverse biased. So this is creating problem. If sudden voltage is applied, charging current through the junction capacitance Cj must turn on the SCR. That means ic equal to dq by dt. When we differentiate it, what we get? I equal to c dv by dt. By increasing the rate of change of voltage, sudden rate of change of voltage, the ic increases and cause the breakdown of charges in the junction j2 and the thyristor starts conducting. Also we have temperature and light triggering, which is very simple. By increasing the temperature, we can trigger the scr, and also with the help of light also we can trigger it out. So these are the points which are very easy to remember. Thank you very much.